Good morning.
Good morning.
Hi, good morning.
Morning, morning. Okay, we have to discuss file system today. File systems. File system formatting. Let me just create partitions once again. Disk is not available. Just add one more disk to this machine. Okay, just to give us VLK. So it's showing one hard disk here that is default in this machine. I'm just going to add one more hard disk for this practice purpose. I'll add SATA disk so it will detect easily. Okay, I'll fire LSBLK again. Once again, yes, detected. There is new hard disk. You can, SDA. Size is 20 gigabyte, and no partitions are defined. I'm going to create new partition. I'll create one primary and one extended. We can create only one extended, and I'll divide extended to multiple logical. After that, we will discuss about file systems. Okay, so just to create a partition. And for new and primary, first primary, okay, I'll give plus 4 gigabyte 4 GB. Okay, same way I'll create new extended and I'll give complete space to extended. Look into partition table. There are two partitions defined. One is primary, another is extended. And now I just want to divide extended multiple logical. So I'll start again, new. Okay, I'll give plus 4 gigabyte. Okay, one logical is created, second logical. Again, I'll give plus 4 gigabyte. And I'll just give capital F to find free space on this extended. It says there is 8 GB free space on extended. I'll create again 4 gigabyte. Okay. And again, just to give capital F for finding free space. It says there is 4 GB free space available in extended. So just create one more logical partition. Done. Print. Clear. And I'll just give WQ for save and quit. Done. Don't forget to give part probe. Okay, so this is what we learned yesterday, right? So now just to give LSBLK, you can find all partitions here. SDA is a hard disk drive, 20 gigabyte in size. SDA1 is the first partition, that is 4 gigabyte. SDA2 showing 1 kilobyte, that is actually extended. Already divided to multiple logical, so there is no free space available in extended. That's the reason showing 1 KB. SDA5, SDA6, SDA7, SDA8. We have discussed why it is start from SDA5 and also how many partitions we can have maximum. This all we have discussed yesterday. Today, let's start with file systems. Partition is ready. Partitions, okay, partitions are ready. What is next? We want to store data. Can you store data on this hard disk now? No. So example, partitions are ready. Okay, imagine we have created four divisions, four partitions, 1, 2, 3, 4. Try either primary, extended, logical, doesn't matter. Okay, leave it. There are four partitions. What is next? I just want to store some data to this, partition. Example, this is like C drive. Okay, if you discuss in window precise, it's very easy to understand. C drive. I just want to store some data to this. Can you store data? No. Now only it is okay partitioned, but we should have some filing system, file system or filing system. Okay, let me give you, see, I have, severe throat pain, so facing some difficulties to talk loudly. Please adjust today. Okay, sorry. And, like in offices, we will do filing, right? Filing. We will buy so many folders. So we call it as a file holders. There are different types of file holders, and different offices will follow different filing system, right? Different offices will, in example, in one office, they're following like daily they are doing filing. Some offices are doing filing only in once in a week. Some offices are doing filing in okay once in fortnight. Okay, some offices are monthly. Example I'm saying. And also they'll use different system, filing system, different order. Understanding, some people are keeping the files in wooden rack. Some files are okay, some people are keeping files in okay steel rack. Example, you see, this is what we follow in offices, because we have so many files in office. Let's take one okay municipality or corporation, or what, panchayat office. So there are so many files, so they're keeping files in a particular manner. You see, okay, one like one civilian just to come to the panchayat office. He's asking something, then they will ask a few questions, and they will okay open wardrobe, and they'll take the okay file. They know where exactly the file is available, understanding, because they are keeping in a special order, manner, order. So also let's take library. Understanding, library, we store books in a particular order, right? Particular manner. So that's the reason it's very easy to find a particular book. Example, college library. I need BSc Physics. Okay, first year BSc Physics book. I don't have to search a lot. There is a special label on every rack. First year BSc Physics, second year BSc Chemistry, like this and all. They have put a label, so it's very easy to take a particular book. It's very easy to insert a particular book, because they are following a particular manner to store the books. Same way, we are storing lot of files. We are dumping lot of files in hard disk drives. So we must follow some system. We have to store systematically. We have to store systematically. We have to follow some manner. These are technically called file system or filing system. Every operating system vendors have proprietary file systems. I've told you yesterday, in case of Windows, Microsoft has FAT. It has so many versions like FAT 8, FAT 12, 16, 32, file allocation table. Second one, they have NTFS. Okay, they have HPFS. They have REFS. REFS. Okay, file allocation table, new technology file system, high performance file system, resilient file system. These are the files. These are the native or proprietary file systems of Microsoft Windows operating systems. Okay, except FAT. All other file systems can be accessed only from Microsoft Windows, but FAT can be accessed from many platforms. Like even you can access, Linux operating system can read data from FAT. Okay, any version of FAT, but NTFS, HPFS, REFS doesn't support in Linux. Okay, so here in case of Linux also, Linux Okay, not Red Hat Linux, Linux, entire Linux. Okay, Linux has its own proprietary file systems. Example like Ext2. Ext2 means extended file system version 2. Ext3 extended file system version 3. Ext4 extended file system version 4. Okay, and there is XFS, JFS, and there are many, please. But we are going to study only these four. Reason, these are the four file systems we normally use in Red Hat operating system. But Linux is an open source. There are so many file systems which contributed by different developers. We are not going to study complete file system, no use. There is NFS. NFS I'll teach later. Okay, that is network access, but this is local file systems. So these are the file systems. Okay, let's say there is one library. Okay, in library we'll have a person to take care. Okay, okay, so we will just give advice. Okay, example, library belongs to me, then I'll just give an advice to him, like you have to store books in a this order, this manner, because he's human being, so I can just talk to him, I can just tell him, I can give advice, understanding. But in case of machine, okay, we can't tell the hard disk. I cannot directly tell hard disk you store this data here, this data here. So what we do is, okay, file systems are really available in the form of programs. Please try to understand, all file systems are well-written programs. Okay, well-written programs. All file systems are well-written programs. So formatting means what? You are applying a particular file system on a particular partition. Okay, example, formatting this partition means applying any of this file system on this partition. Formatting this partition means applying any of this file system on this partition. So what is formatting? Formatting doesn't mean cleaning data. That is really wrong thought. Okay, wrong. Okay, it's really wrong. People are thinking cleaning data, clearing data, deleting data is called formatting. When you format, absolutely, I mean, like, probably you will lose your data. That is quite normal. Understanding, but formatting doesn't mean deleting data. Formatting means applying a particular file system for a particular partition. Okay, applying a particular file system or filing system means file systems are programs. You're applying a particular, okay, file system to particular, okay, what partition. That process is technically called formatting. So example, this partition has already ext2 file system, and you have stored lot of data. When you are going to apply another file system or same file system again, okay, probably what will happen is, all file system will not be, okay, accessible. New file system only will be, okay, will be accessible. New file system will be accessible. All file system will be, bottom. New file system will be up. So your disk read write will always, okay, read data, write data, okay, from the top layer of the file system. That's the reason after formatting we are losing all datas. Okay, actually we are not losing. Okay, data is always available on hard disk. You can recover, okay, anytime with the help of softwares or tools. Okay, people are like even recovering data from dead hard disk. Okay, formatted, okay, repartition hard disk, and also deleted, okay, data also. We can recover everything. We have system for that. Okay, that's not our discussion now, but try to understand. Okay, so when you are applying file system, okay, when you are applying file system means you are just teaching your hard disk drive, you're teaching your hard disk, okay, drive, read write head to follow a particular file system, filing system, to store data on a particular partition. Let me tell you, so I'm planning to format this with ext2. I'm planning to format this particular partition with ext2. I'm planning to use, I just want to apply. When I'm formatting, what will happen is, you please try to understand some, okay, so starting sector. starting sector of first sector of this example, first sector of this partition. Example, this is the first sector of this partition. First sector of this partition is completely utilized for utilized to store the metadata of this particular file system. Every file system will have metadata. You know, metadata means data of the data, data of the data. Okay, so every file system will have its own metadata. So metadata means, you know, your hard disk read, hard disk head, okay, will understand, will study the file system details from its metadata only. So example, here metadata of Ext2 is stored. Metadata of the Ext2 file system is stored here in first sector of this partition. Okay, so to store metadata, normally, file system will take some space, maybe like, you know, some MB, like maybe 2, 3, 4 MB or 10 MB, 34 MB, like this. Okay, it will take some space. That's what I said, it's a program. Okay, so metadata of the file system is stored in, okay, the first sector of this partition. First sector means starting sector. Starting sector of this partition will have the metadata of this particular file system. You know, suppose example, you are requesting the hard disk, you're requesting the read write head of this disk. You're requesting this, you're requesting read write head of this disk to read or write something from this partition. Okay, what will happen when you request, what will happen when you request, okay, read write head of this hard disk to read or write something from this partition? You know, listen, it's very easy to understand now. When you're requesting to write something to this partition, or when you're requesting to read or write something from this partition, your disk read write head will read the metadata. It will study the metadata first. It will study the metadata first, which is available in the first sector of this partition. Understand? And it will study it. Study means your disk read write will study how exactly this particular partition should be handled, in what order, what system file should be, okay, stored, and what order, what system I can retrieve file from this partition. Complete informations will be available in this, okay, starting sector. That is what metadata. So okay, disk read write head will always read, okay, metadata of the file system which stored at the starting sector of the partition first. After only it will start to, okay, read or write. If this file system is corrupted, what happens if file system is corrupted? It's a big problem. Okay, I remember really in XP, Windows 2003, sometimes we get file system related issues, file system not found, file system, okay, corrupted, understanding. So if file system is corrupted, really no problem. Nothing will happen to the stored data. Okay, file system is corrupted. Means your disk read write head says, I'm sorry, I don't know what order should be followed, what system, what file system should be followed to read write from this particular, okay, partition. It says that is what file system corrupted. Understanding that is that is what mean file system corrupted. So, but nothing will happen to your data really if you can, fix this problem. Your complete data can be accessed. I mean, you can access your complete data if you can fix this problem. Okay, in case of Windows, it's very easy. Okay, we have, you know, command for that. In Linux, file system errors are very rare. We have so many mechanisms, so many systems to recover file system from errors. Like there is something called journaling. Okay, we have, you know, like a file system dump and file system, frequent file system scanning is another idea. Understanding to ensure the health of the file system. Understand, you try to understand. I've told you disk is not important, file system is not important. For me, my data is important. You have stored lot of data here. So if your file system is healthy, okay, I mean disk read write head can read or write anything from this if file system is healthy. Just imagine your file system is deceased. There is a deceased file system, then what? Disk read and write head will say, sorry, I'm not able to read or write anything from this particular partition. But I have told you, okay, data will be safe and you can fix the file system related errors with the help of the any technology. Okay, as I said, there is journaling, for there is file system dumping, and in my office, I'll tell you, I usually scan thrice. I usually scan. Okay, I mean scan file systems of our data center thrice. So I've just created a small script in PowerShell, and I'll usually run thrice because it's my responsibility. Like I should ensure file systems of every data centers are healthy. Understanding unhealthy file system, diseased file system can really stop entire work for a day or multiple days. Really. So data is everything. If no data, your employee cannot start to work. Data is everything. In business, we are producing data daily. Huge amount of data is getting produced. Understand? So today's data is needed for tomorrow. Okay, so that is very important. So that is what file system. So please try to understand these file systems. There are some differences between file systems. I just create a small table here and try to explain. Okay, let's say like FAT and NTFS. You might be knowing FAT and NTFS. There are a lot of differences. FAT doesn't support file encryption. FAT doesn't support file compression. FAT doesn't support setting disk quota for users. FAT doesn't support local security, permissions. Understanding? FAT support only share levels. Okay, permission. No local security, file level permission. Understanding? So NTFS has all of this, features. That's the reason no one using FAT now. Okay, and come to HPFS and REFS. Okay, there are some features, understanding. So now, okay, I'm just going to explain you the differences between these file systems. So finally, you can decide which is the best file system to format a particular partition. And also you try to understand, we use the file system based on circumstance and requirement. Okay, need. So let me just create a small table here. Okay, first I'll say like features and Ext2 file system, Ext3 file system, Ext4 file system, XFS. Again, there is JFS and all. Okay, forget please. I'll teach only this. We can't study all file system. We can't finish it. There are so many file systems. Okay, Linux supports because it's open source. There are so many file systems contributed by so many professionals. Understanding all are not in. Okay, all file systems are not in use. You try to understand. So no use of studying all file system. Understand? So features. First feature is journaling. Journaling. It is a bit difficult to explain and understand now. Okay, don't worry. We have 45-minute troubleshooting session in this chapter, disk and storage management. Okay, last class I'll explain you what is journaling, how exactly journaling works. It is a bit difficult now, really. Okay, but I'll tell you, journaling. Okay, you try to understand. It's a technology. Journal ledger in accounts, right? In accounts, journal ledger. Okay, so what is journal? A very individual transactions, we create a journal entries, and multiple transactions we create in ledger. Understanding? So like that here, journaling is actually is a technology. Okay, journaling is a what? Journaling, you must say file system journaling. That's very important. You must say like that, file system journaling, FS journaling. So what is file system journaling? It's a technology used to recover file system from errors. File system from errors. That's enough now. Okay, if I explain completely, that is a bit confusing. Okay, kindly wait. I'll tell you. We have disk and storage management. We have a last session in that I'll teach you what is journaling, how Excel it works. I'll just draw some diagram and try to explain it. And file system scanning, file system conversion. We will discuss these things in last session. Okay, then I'll try to explain what is journaling. So file system journaling is a technology which will help to recover file system from errors. That too, it's really self-healing. What? Self-healing. Understanding? User you okay use user I mean user intervention is not required. Okay, user doesn't want to intervene. That is important of this journaling. So here it doesn't no journaling in Ext2. There is journaling in Ext3. There is journaling in XFS. This is the first. It's really very important feature. Really very important feature. Okay. So what is the only, because you will not understand now. Actually, it's a technology used to what, recover file system from errors. You just try to understand. Okay, imagine. Let me tell you one small example. Okay, Bangalore Palace ground, huge ground, and there is some exhibition. Okay, going on. There are four exhibitions. Like in one tent there are four exhibitions like fruits, vegetable, plants, and what, flowers. Four exhibitions. So you just want to, okay, but four exhibition halls are in one tent but single entry. They have given a complete map. So I just want to go to flower exhibition stall. I don't want to visit all. So I've taken ticket for the token for that. So next thing, I should know how to reach in. Okay, because it's a very huge place. I don't know where exactly. Okay, flower show means, I mean, flower exhibition is happening. So, but it's a single entry. So they have given a complete map at the entrance of the tent. They have given a complete map. So I'll study the map so that I can directly land in, okay, flower exhibition, stall. Understand it? Because I got the map. Okay, just imagine no map. Then what? Complete confusion. So, okay, we are human, so we will just ask people and go. But hard disk cannot do anything, right? Understand? So it's like that. If file system is corrupted, that means no map. File system corrupted, no map. See, file system will give all information. Okay, total size of the hard disk, how much blocks, how many blocks are available totally, how many blocks are, okay, already filled, how many blocks are filled partially, how many blocks are available now, how many blocks are like damaged, we call, okay, what bad, okay, bad sectors. Understanding, every informations will be available in file system. So file system will be getting up to date. Okay, example, there are 1,000 blocks here. Okay, all 1,000 blocks are free. Now some blocks are used. Then those information will update in file system metadata by saying like so and so block number 1, 3, 8, 10 already used. Okay, should be okay, filled properly. Otherwise, it's a big problem. So that is what metadata. Just imagine if metadata is not there, how discrete rate will come to know, head will come to know how many blocks are available, how many blocks are like filled, partially filled. That's really crucial information. So that's what, if file system is corrupted, nothing can be done. It's a big problem, but nothing will happen to the stored data. If you can recover it from problems, I mean errors, really your data will be available. So no worries about data, but it's not easy really. Understanding, it's not easy. Recovering from errors, it's really not easy. Understanding. Okay, next, that is file. Okay, file system journaling, and I'll just tell you in which year it's unveiled. Okay, which year these file systems are unveiled? It's in 93. It's not exact actually. Okay, this is in 2001, and this is in 2008. This is in 2012. File system unveiled. So this is not important. Okay, just for understanding, I said. Next is maximum size. Maximum size of single file. One file size, maximum size of one file. Okay, sorry, 2 terabyte, 2 terabyte. Here also 2 terabyte only. And next is 16 terabyte. And this is 2 exabyte, 2 exabyte. Huge. You know what? Okay, XFS. You might have noticed, if anybody working in Linux, you might have noticed, or you might have realized, most of the companies are using XFS file system in their, okay, storage enclosures and data centers. Because in data centers and storage enclosures, sometime we will store archives. Size of the archive would be really in terabyte. Size of the archive will be always in terabyte only. Understanding, terabyte, because we keep add file to the archive. We have studied, right, tar. Okay, so this is really good utility, I mean very important strength of this file system. Maximum file, maximum size of the single file. Okay, fat doesn't support 4 GB, you know that, right? So FAT has lot of disadvantages. Next is maximum size of entire file system. Entire file system means maximum size of single partition. That's the meaning. Okay, 32 terabyte. 32 terabyte. Okay, this also 32 terabyte only. 32 terabyte. And this is 1 exabyte. And this is 8 exabyte. These are the important, okay, in this first, third, fourth, these are the important, okay, important features of the file system. Okay, this year of unveil, you forget, it's not a problem, no one asks you when this file system is unveiled. Okay, so you please keep this, three, number 1, 3, 4, very important. You must, by heart it, because it's a frequently asking review question about file systems. File system differences. One is journaling. I didn't explain it well, but I have just said it's a technology used to recover file system from errors. That's enough now. Okay, Ext3, 4, okay, XFS supports. And this also really very important. This also very important. So finally, if I ask you which is good, probably you will say what XFS is good, because XFS support file system journaling, support large single file size and large what, okay, single, I mean partition size. This is really important. So that's the reason XFS is normally XFS stands for extended file system. Okay, so this is what normally used in data centers in enclosures. Okay, I'm saying from my experience, I didn't work on this actually, data centers, but I've seen in offices we have enclosed all, disks, that is pooled disk, actually complete disks are formatted in XFS. So I'm saying in guarantee, okay, because I've seen in office. Okay, next is, there are again so many differences, but that's really not, like how many files maximum can be created, and what's the size, what can be the maximum size of this file name. I mean, how many characters, like 256 characters. That's not really not required. Okay, these three very important, three are very important, keep in mind. So now I think you have got an idea what is file system, what is formatting, and file system differences. If anything, you must ask, because next we are going to format. Please, if any questions, please ask. Anything like repeat, I can repeat also. Please try to understand what is file system. Okay, I think no questions. Then I'll show you practically. We have created enough partitions now. I'll just I'm just going to format first partition STA1. I just want to format STA1. It's not formatted. We know it's not formatted, but how do we check whether it's formatted or not? For that, you can give blkid command. Okay, blkid stands for block ID. This command will, okay, list all partitions and its file system. Okay, so all partitions will be listed along with file system. But you can see, okay, if partitions are not formatted, only partitions list, okay, you will get only list of partition, no file system. Understand? Look here, it says this partition, XFS file system is used for this partition. Okay, this partition, okay, which, sorry, this is actually, LVM, that's the reason, okay. And here, XFS swap. But you see the partition which we have recently created, STA1 to STA8, all are visible here. STA2 is not visible because it is extended. Extended will not be listed normally, understand? So STA1 is primary, 5, 6, 7, 8 are logical. All are listed here, but it's not showing the, okay, it didn't mention any file system name. That means not formatted. Okay, these partitions are not formatted, so no file systems are mentioned here. Understanding? There is a partition UID, UUID. I'll tell you. So how do we identify a partition? We use partition, name like /dev /STA1, 2, 3, 4, so on. But your machine is really your machine identifying the partition with the help of a unique ID, that is partition UUID, stands for partition universal unique identifier. Okay, and this really, you don't worry about it, you don't have to memorize or by heart this particular number. Okay, forget please. Okay, now what we use this number, we always use what? Okay, partition name to represent to handle the partition. So forget, understand. So you try to understand machine, identify the partition based on its UUID. Okay, now anyway, I just want to format STA1. It's not formatted yet. So we want to format it. Okay, I'm going to format. So there are many commands. First command I'll say like MKFS stands for make file system. Make file system. MKFS. Hyphen T stands for type of the file system. So I just want to use Ext4, Ext4. Clear. MKFS space hyphen T stands for type of file system space Ext4 space, and you have to mention name of the partition, UUID or name of the partition. So name of the partition is STA1, right? STA1. This is what we want to format. Clear? So this is a syntax. Okay, so if you want, I'll just type the syntax here. Command is mkfs space hyphen T stands for type of the file system. You have to mention type of file system. Okay, and next you have to mention name of the division, name of the partition, name of the partition. This is a syntax. Clear? Now I'll just enter happened, finished, and it's showing so many information here. So after formatting, UUID will be assigned to the partition. Okay, it says MK2EFS. This is a program which we have used. Commands are programs, right? I've told you in last class, all commands are programs. So it says this is a MKFS. Okay, program used 1.45 for get and creating file system. How many blocks? It's very difficult to handle size and partition with the help of I mean like handling partition in number of blocks, sectors. Forget. We know like we always identify the partition by using partition name and its size. Okay. Now, here there are some more information I'll read and tell you. Please wait. Before that, I just want to give my blkid command once again. Then you can see STA1, UUID is assigned, and you see type of the file system is applied. Applied file system is Ext4. What's the actual size of this partition? 4 gigabyte, right? Actually, the size of the partition is 4 gigabyte, and we have applied Ext4 file system is formatted. Formatted. Okay, so same way you can format other partitions also. I'll format, STA5 with XFS. For that, I'll use another command, MKFS, but I'm not using hyphen T option. Okay, hyphen T switch. I'll just say like XFS, MKFS dot XFS. So I've mentioned type of the file system along with the MKFS command, so I don't have to use again hyphen T option. Okay, I'll just give slash dev slash STA5. Okay, so that's all. Just enter. Okay, happening quickly, right? It's a quick format. Reason 4 GB, and it's a new hard disk, new partition. Understand? Okay. Another Linux operating system. Linux is really faster. Okay, formatting everything faster. So check again blkid. Then you can realize STF5 formatted with XFS file systems are applied. So now we have created partition and formatted partition. We have created and formatted partition. What's next? So we can store data, right? We can store data. We can store data. But before that, I just want to tell you, say for example, I've just opened window, File Explorer and Windows operating system. Okay, these are partitions, you know that. Okay, so if you create, imagine there is free space available in this hard disk, and you're going to create one more partition. Then partition, after creating partition, you will format it. After completing the format, after completion of, after formatting, what will happen is that partition will appear in File Explorer along with a drive letter. Clear? Means there is drive letter system. So you can double click and access, you can store, you can read, you can write, anything you can do, right? So it's like, opening, reading and writing. understanding. But so this is actually in Linux, in Windows we have drive letter system. We use drive letter, okay, to represent partition. We are not doing anything. Operating system is automatically allocating drive letter to the new partition after formatting it, and it will be available in File Explorer. You can go and access. Finish. But Linux case is really something different. You must mount it. You must mount this partition. Mount. So in case of Windows, mounting is automatic. It's automatically partition is mounting with the help of a particular drive letter. Okay, partitions are getting mounted automatically with a drive letter. It's mounting, linking. Okay, linking a particular partition with a drive letter, so it will be available in File Explorer. You can easily identify the partition. You can double click open. You can store data, but that is not easy in Linux. Now partition is ready, formatted also, right? We have formatted. You can't access it until you mount. Until you mount, you must do it manually. You must mount it manually. Mount the partition manually. So what is mounting? Listen, I'll tell you simple example. Okay, partitions defined, file system applied. What is next? So this partition okay, I just want to store some data. I just want to retrieve some data or store some data from this partition. So there should be something which represents this partition, because this partition is physically available on your physical hard disk drive. It's a physical, okay, space which is logically divided, right? Physical space which is logically divided. That is what partition. Understanding? It's available on physical hard disk. There should be something in your operating system to represent the partition. Clear? So that is what drive letter in case of Windows. Okay, but in Linux case, we don't have drive letter system. We use what? Folders to represent partition. Folders means directories. That is called, okay, mount points. Example, I'll create one directory means folder, and I'll just mount this particular partition. I just mount this partition. Mount means linking. I'll just link this partition to this folder. Folder name is example data. Folder name is data. Now the folder data folder or directory, data directory is representing which partition? This partition. /dev/sda1 example. Understanding? This folder, this directory is representing this partition. What is the size of this partition? Example 10 GB. Means you can store 10 GB. You can store only 10 GB data into this folder, because this folder is really representing this partition, and size of this partition is 10 GB. So you can store only 10 GB data into this folder. Okay, if you try to store more than 10 GB, it will say sorry, no, okay, sufficient space available. Means there is no space available here, it's a 10 GB only. Okay, so this process is technically called mounting, and this directory is called mount point. Mount point. Mount point. Nothing, simple. Understanding? You try to understand no drive letter. Okay, we don't use drive letter like C, D, E in Linux. We have folders. Instead of drive letter, we have folders. And okay, what I'll do is I'll just remove this link, then unmount. Okay, unmount. Okay, example, mounted. Okay, unmounted. Understanding? Mounted, unmounting. Understanding? So suppose now, okay, this directory is not representing this partition. Okay, so does it mean you lost all data whatever you store in this directory? No. Directories, like directories are just used to store data in a particular files, particular manner, right? Directories are like our file holders we use in offices to keep the files in multiple files in a particular manner, maybe like month wise, week wise, understanding, day wise, understanding. So that is what. So no value for directory, understanding, value for files only. So now this directory is not representing, okay, this partition. So that doesn't mean you lost your data. Data is 100% safe here. Okay, if you link again, link means if you mount again, if you link again, okay, okay, you can view the contents of this, what partition in this directory. So this is called mounting. I think it's clear, simple. Now there are two ways to mount. One is temporary mount.
Ashok
Temporary
sir,
mount. Yeah.
if we accidentally delete that directory,
Oh.
So will it end up
Nothing will
losing that file?
nothing will happen. Suppose you have deleted this directory. Okay, you have deleted this directory. Oh, this directory means like content, right? Directory along with content, you are saying. Suppose you have stored a lot of data here, isn't it?
If we are performing like rm-rf or something.
Okay, yeah, suppose you have given rm hyphen, so deleting this directory is actually mount point. So when you delete mount point, okay, what will happen if you unmount? What will happen? Nothing will happen to the data. But if you delete equal to deleting the directory along with contents only, then okay, things will be gone. Understand what I'm saying is, if unmount, okay, if you remove the link. Okay,
Okay.
removing the link and removing the directories are two different distinct process. So
Okay,
that's like a
okay.
normal deletion only. Okay, so there are two ways to mount. One is temporary, another is permanent. Okay, so I'll show you first temporary mount. So temporary mount will not persist, means temporarily mounted partitions will not persist, or temporary mounts will not persist after restart. Okay, so if you want to access the data from a particular partition always, it's better you can mount permanently. And there is a partition which contains some data we access like once in a while, then you can go for temporary mount. So that's your completely your discretion. Okay, so user can decide what type of mounting you want to do for a particular partition. That's your discretion. Okay, so let me show you temporary mount. It's very easy. Look here. So first of all, we must create a directory. We must create a directory. Understanding directory. So I'll just create a directory. Let's say like mkdir, and there is /mnt directory. Okay, sorry. Let me tell you first is /mnt. Sorry. Look here, there is a directory called MNT, right? I have briefed once. MNT is a directory which is used to store, okay, all mount points. MNT used to store all mount points. Understanding? So mount points means like, what is mount point? Directory which is linked, directory which represent, or directory which link to a partition. That is called mount point. So MNT is a directory, okay, which is used to keep all mount points. But you can create mount points in any of this directory, that's your wish. But I'm going to keep in MNT only. So you just ls MNT first. Okay, there is one directory, default one, forget. I'll create a new directory there. I'll go for /mnt. I'll give data. Directory is created. Check again, see data directory is available. Now I'm just going to make this directory as mount point of a particular partition. Which partition? First partition is TA1. I just want to make this as mount point of the partition. Which partition? STA1. STA1. Okay. So here I've told you there are two ways to mount. One is permanent, another is temporary. Okay, temporary mount, permanent mount. Understanding temporary and permanent mount. Now what I'll do is I'll just give a command df hyphen th. Sorry, df hyphen th. Df stands for disk free. Disk free. Hyphen t stands for type of the file system. S stands for human readable. Human readable. I'll just enter. Then it's showing so many, like it's showing a table which contain, okay, which has multiple columns like file system column. Okay, there is another type of the file system. Okay, file system is like a partition column. Type of the file system is very easy to understand like that. Here they have given file system type. It's better you read it as a partition, and type of file system, size of the file system, and used space available, usage in percentage, and mount point of that particular partition. You read it as a partition. Okay, so here our partitions like dev sta1, dev sta2, okay, those partitions are not visible here because we didn't mount so far. We didn't mount. Understanding? So we are going to mount it now. We are going to mount. So mount point is ready, partition is ready. Mount point is ready, right? We have created a directory, mnt data. You can create a directory in any name, any location, that doesn't matter. Understand? Next is mounting. I've told you I'll teach first temporary mounting. Temporary mounting. Okay, I'm going to mount. I'll use a command. Mount. Mount space. What you want to mount? I want to mount slash dev slash sda1 partition. Okay, where you want to mount? Slash mnt data. That's all. Enter. And take again, df-th. Look at last line. Dev sta1. File system ext4. Actual size 4 GB, right? Actual size 4 GB. Okay, so I've told you some space will be utilized for file system. Finally, 3.7 GB is available. Okay, file system metadata will be stored on same partition, right? You try to understand. See, this partition formatted with ext2. This partition formatted with ext4. This partition format with XFS. So you please try to understand at the entering sector. Entering sector means first sector of a particular partition. First sector of the partition would contain file system metadata. File system metadata. So file system metadata will be available after formatting only, right? File system metadata. So why it's keeping at first sector, because if your disk read write head wants to do read or write any process on that particular partition, it must study the file system first. File system first. Okay, like what's the use of keeping the root map inside the inside the like what is like tent? No use. It should be always out of the tent, right? Root map, how to reach in particular stall. Understanding? Same thing. So it will be always at entrance to store metadata. Every file system will use some space to store metadata. Every file system will use some space to store metadata. Understanding? Metadata. So here now it says mounted MNT data is the file. Okay, I mean like a mount point of this particular file system. I mean like this partition. Mounted now. You can start to store data. I'll just store some data. Touch slash MNT data. I'm going to store 100 files .pdf. Okay, now just ls slash mnt data. It says there are, sorry. Oh, you just say ls data. It says there are so many. Okay, I'll tell you what is lost and found. Okay, you might be knowing lost and found anyway. Every file system will have lost and found. I'll teach later. Okay, the file system troubleshooting, recovery and all. I'll teach what is lost and found. So there are 100. Okay, so people usually ask a question: can I mount a particular partition to multiple mount points? Yes, but no use, right? You can mount to multiple. You can mount particular partition to multiple. Okay, now see df-th. What it says? It says dev sta1 is mounted to mnt data. Now I'm going to mount same partition to another. Okay, another mount point. Let me create a directory first. I'll create a directory. Direct name is data1. Okay, created. Now I'm just going to mount again. Mount slash dev slash sta1. No use. Okay, I'm just showing because this is a tricky question. That's all. Okay, opt data1. No error message, nothing, right? But you check df-th command again, just to give df-th again. Okay, it's showing MNT data only. Okay, so first, like primary mount point. Understanding, but you just give ls slash or pt data one. Okay. Showing complete contents. And like this, you can mount to, okay, I've heard like we can mount to 32 mount point, but I did never tested it, okay? Because you probably you may ask stuff like, yes, you have mounted to two and how many? No use, right? But I've heard we can mount to 32. One partition can be mounted to 32 mount points. Okay. So at a time, no use actually, but you try to understand. Even I didn't test also. Okay, so tomorrow if someone test and say like I couldn't do after 8 means, okay, I'm just saying in advance I didn't test it, but I have heard we can mount to 32 mount points. Now what I'll do is I'm just going to unmount. Okay, unmount, okay, temporary unmount, umount slash mnt data. See, when you are unmounting, just mount point name is enough, no need to give device name. I've unmounted. Then you check again df-th. I've unmounted. Okay, it was mounted to two places, right? I've unmounted. Okay, now then it's showing another place. Understanding? So primary is unmounted, so it's showing secondary mount. I'll unmount secondary also. I'll just give slash opt data. Opt data one. Unmounted. df-th. Unmounted completely. Understanding? Just ls slash mnt data. It's not showing anything. Understanding? Okay, and slash opt data. Keyboard has some problem. opt data one. Okay, nothing. So, but your data is 100% safe because we have unmounted. So data is 100% safe in your partition. Whenever you want, you can mount and access it. Okay, we have just okay remove the link. That's all. We have just removed the link, so it's not a problem. Understand? So let me just mount it again. I'll just give mount slash dev slash sda1 and slash mnt data. Mounted again. Just ls. Okay, showing complete contents. Okay, next is what permanent mount. Permanent mount we will do tomorrow because there are so many things. Okay, I need minimum half an hour to discuss that. There are a lot of things for permanent mounting. Okay, just practice with this. I think there are some files in some PDF should be sent. I'll send now. And I have another batch at 8 o'clock. Yesterday I've started very late. Okay, so we will meet tomorrow. If anything you can ask, please. Any questions? Okay.
Here, just one thing I want to know that TMPFS some files there, no, for the
Temporary file system. There are so many TMP. This all I'll explain. It's coming. Okay, temporary file system. Understanding. That
and
will I'll
they're
tell you.
put in separate. I mean, different place.
Yeah, you're saying there are many times, right?
Hmm.
Yeah, I'll
And
tell you. I'll tell you that.
point also the I mean in separate folder.
Mount point you are saying.
Yes, yes.
That's what I'll tell you this. I'll tell you this.
Okay.
Okay. That's all. We'll meet tomorrow.
Yeah.
Bye.
Yeah. But
Thank you.